All right, so continuing on with chapter 12, talking about probability. So in the first video, we kind of went through some basics and wrote a few of the rules. A couple of those are probably pretty obvious. And then we had the complement rule, and the complement, if you don't remember, is the complement of event A would be the opposite of A, or the event where A does not happen. So um, we did one earlier where we had the probability of green is 0.35, and then we found green complement, which is the event where green does not happen. So this brings us to rule number 5, and this is the multiplication rule. And what the multiplication rule says is if A and B are independent, then the probability of A and B equals the probability of A times the probability of B. So last time, rule 4 was the addition rule, and that had the probability of A or B. So we said last time with the addition rule that or means we're going to add, and now we're going to see the and means that we multiply. So those are two very important things to remember. We will use those a lot, and it just makes things a lot easier if you can remember that and will always mean multiply or will always mean add. And there are different ways we can multiply, there are different ways we can add, but generally speaking, those are the rules for those words translate to that mathematical operation. So independent events means, so A and B are independent, are independent if they do not influence one another. Now, that can be a little bit maybe unclear, maybe not quite as nice as we could put it. So the idea is A and B are independent if, knowing that A happened, or if A happens, it does not change the probability of B happening. So think about the flipping the coin. So whatever you get on the first flip does not change the probability of what you get on the second flip. But an example where they would not be independent would be if you have a deck of cards and you have a stack of 10 cards or 15 cards or whatever, and you're going to flip a card over, and let's say that you have 10 cards, 5 cards are red, 5 cards are black. You flip over a card, and let's say it's red. So then what's the probability you get red on the second flip? Now you only have 9 cards, and 4 of them are red and 5 of them are black. So it went from 5 out of 10 to 4 out of 9. So the probability changed based on what you got on the first flip. So those would not be independent. So independent events, if one happens, it does not change the probability of the second one happening. So for example, here we have the probability that an Atlanta to Houston flight is on time is 0.85. If you have to fly every Monday, find the probability that your first 2 Monday flights will be on time. And so we could say these are independent because the probability of your second Monday flight is 0.85 regardless of whether the first Monday was on time or not. So that first Monday does not affect the second Monday. And obviously the second Monday doesn't affect the first. So these are independent events. So we want 2 Monday flights. So 0.85, that would be the probability that you're on time the first Monday times the probability you were on time for the second Monday. And you multiply those together and you get 0.7225. All right, so that's an example of independent events. All right, moving along. What is the probability that you do not encounter a red light until Wednesday? And we'll assume we start on Monday. So on these probability or problems like this, where you kind of have a sequence of events, or we'll see here on number 9, where we're going to call 3 people or survey 3 people in a minute. It's a good idea to kind of, what do you want to happen in each space? So here we have 3 days. We have Monday, Tuesday, Wednesday. So Monday, Tuesday, Wednesday. What's the probability you do not encounter a red light until Wednesday? So what do you want this one to be? On Monday, you want it to be not a red light because you want your first red light to be Wednesday. So that means that one will be red, and then these 2 will be not red. So green or yellow, it doesn't matter which. We're just going to say not red. And so now what's the probability that you get a non-red on Monday and a non-red on Tuesday and a red on Wednesday? So these are ands, so Monday and Tuesday and Wednesday. So that'll be times and times. So probability on Monday times probability on Tuesday times the probability on Wednesday. This is a sequence of events, and there's one way for it to happen, and this is the one way. So what's the probability you do not get a red on Monday? So if you remember from earlier, the probability of red was 0.61, if I remember right. What's the probability that you do not get red? So the probability of red complement would be 1 minus 0.61, which is 0.39. And of course, you probably would notice if you remember or look back, the probability of green was 0.35, the probability of yellow was 0.04, and you add those together and you get 0.39. And of course, those are the 2 options besides red. So this would be the probability you do not get red on Monday would be 0.39. Probability you do not get red on Tuesday is still 0.39 because it's not changing. Getting red on Monday or getting yellow on Monday does not change the probability of what you get on Tuesday or Wednesday or the rest of the week. So the probability you do not get red on Tuesday is still 0.39. And then the probability that you do get red on Wednesday is 0.61. And so we multiply all those together and we get 0.0, and we'll just write the whole number, 92781. So this is the probability that you get yellow or green on Monday, yellow or green on Tuesday, red on Wednesday. So it's 3 days. This is an and. So again, this sometimes will help if you have trouble when you see a problem. Is this an and problem or is this an or problem? You want, so you could say this to either way and see which one makes sense. So do you want not red on Monday or not red on Tuesday or not red on Wednesday? Or could we say it this way? Do you want not red on Monday and not red on Tuesday and red on Wednesday? So is either and or problem or an or problem, and the way that makes sense to say it uses and, not or. So, and then of course, and means multiply. Okay, so find the probability the light will be red at least one time during the week. Now this phrase, at least one, is a very important phrase, and whenever you see this, you're going to use the complement. And the reason you use the complement, we'll explain this briefly, and hopefully this will make sense. So Monday through Friday, so we're looking at 5 days. If you go to a red light 5 days, how many red lights could you come to? So obviously all 5 of them could be red. All 5 days you get a red light, or maybe 4 days you get a red light, or maybe 3 days you get a red light, or maybe 2 or 1, and maybe you never get to the red light. You come to the light every day and it's not red any of the days. So these are the possibilities. How many, if you come to a red light, traffic light, 5 days, how many days could it possibly be red? And so anywhere from 0 through 5, those are the numbers of red lights you could have. So how many of these are included in at least one? So 5 red lights in a week would be at least 1, 4 would be at least 1, 3 would be at least 1, 2 would be at least 1, 1 would also be at least 1. But if you come to no red lights, That is not at least one, and so that would not be included in at least one time during the week getting red. Okay, so all that to say, whenever you see this phrase at least one, so we're looking for the probability at least one red, at least one red light. We're going to use the complement. So that would be 1 minus the probability. Now, what is the complement of at least one red? Now, that's why I kind of did this. So all of these are the ones that we want. That would be our event A that we're interested in. What would be a complement? A complement would be the 0. So there is no red. So the probability of at least one red, we're going to use the complement because there's multiple ways that you can get at least one red. There you can get 1 red or 2 red or 3 or 4 or 5 red lights during the week. We want the probability of all of those. It's a lot easier just to find the probability of no reds. So whenever you see at least one, use the complement. And the complement of at least one is always none. So at least one, whatever it is that you're talking about, what's the probability, you're planning to have 5 kids or 4 kids, what's the probability you have at least one boy? You can do 1 minus probability of no boys. You're going to call 10 people and ask them if they plan to vote in the election, and what's the probability that at least one of them says they are. Then do 1 minus the probability that none of them are. So whenever you see at least one, always use the complement, and the complement is always none. At least one equals 1 minus the probability of none. So we have 5 days here. So Monday, Tuesday, Wednesday, Thursday, Friday. And we want no red. So we're finding this right here. So not red on Monday, not red on Tuesday, not red on Wednesday, not red on Thursday, and not red on Friday. What's the probability it is not red on Monday? Probability of red again is 0.61. Probability of not red is 0.39. What's the probability it is not red on Tuesday? 0.39, and I won't write the whole thing, but all the way across 0.39. So the probability of no reds would be, this is an and again, not red on Monday and not red on Tuesday, et cetera, et cetera. So this would be 0.39 times 0.39 times 0.39. So we could write 0.39 to the 5th because we have 5 days. So we put that in the calculator and we should get 0.991. All right, so we're going to do another one of those similar problem in just a minute. But just to summarize again, if we're talking at least one red light, these are all the possible red lights that we could get. So those are all the good ones. That is the bad one. That's the one we don't want. So instead of finding all 5 of these probabilities, which you could do, but it would take you a lot longer, we can just find the probability of no red lights, 1 minus that. So there's a complement, 1 minus the complement, and that gives us what we want. So what do I suggest? If you have trouble with this problem or any of the other problems, go to something like ChatGPT and type in this problem. So you need to tell it what the probability of red is. So just say the probability of red light is 0.61. Find the probability the light will be written. You just type in this problem, and it will show you how to do it, and it'll do it this way. And then what you can do is ask it to give you 3 similar problems, and it will give you 3 problems. There you find the probability of at least one, whatever it is, and it will give you it'll give you some practice, and that's a good way to get some practice. And then you can ask it. It won't give you the solutions. You say, give me the problems. It won't give you the solutions, and you can try to work them, and then say, give me the solutions. So that's a good use of the AI, programs, ChatGPT or whatever it is that you want to use. Don't just use it. How do I do this problem? And you just copy the answer. That's not a good way to make use of that. There are good ways, and that's one of them is type the problem that you're struggling with. How do you do it? And then say, write 3 more problems like this one, or 5 more, or whatever it is. And then if it doesn't work, or if you don't understand some step, you can ask it to to explain that step further. So I think that's a really useful way to use that kind of thing. All right, so number 9, I took all the numbers off and I forgot the number to just write example on this one. But number 9, M&M wants to make a new color for their candy. According to a survey, 38% of people want pink, 36% want teal, 16% want purple. One thing to notice about this, so you want to be careful. These do not add up to 100%. So 0.38 plus 0.36 plus 0.16 is, what is that, 52 plus 38. So that's 0.90. That's not 100%. So we're missing something, whatever the miscellaneous color is. 10% wanted none of those three, but just an observation, and you might want to pay attention to things like that. So just always make sure that things add up to 100 before you start doing things and making assumptions that will lead to a wrong answer. All right, so find the probability that a survey respondent will want either pink or teal. So pink or teal, or means add. And we're just getting one survey respondent. The one survey respondent cannot pick two colors. That's kind of the assumption. They're going to pick one or the other. So this is the probability of pink plus the probability of teal. So pink is 0.38 and then teal is 0.36. We add those together and we get 0.74. All right. So again, said it, wrote it earlier, we'll write it again, or means add. All right, and then part B, find the probability that two survey respondents will want purple. So is this an or problem or is this an and problem? It doesn't say either one explicitly in the problem, but do you want the first one to pick purple or the second one to pick purple? Or do you want the first one to pick purple and the second one to pick purple? So this is an and problem. So probability of two purples, and we can assume these are independent. So if we just pick random people, we can pretty safely assume that one is not going to influence the other. So the probability of purple times the probability of purple, and probability of purple is 16%. So this would just be 0.16 times 0.16, and that gives us 0.0256. All right, and again, or means add, and means multiply. All right, and then last one, another at least one. So find the probability that at least one of three survey respondents will want purple. So probability at least one purple. Now, remember, at least one, oops, I didn't say really at least, but at least one, use the complement. What's the complement of at least one? Complement of at least one is none. So what's probability? 1 minus the probability of no purples. So we ask 3 survey respondents and we want none of them to choose purple. And so 3 survey respondents, purple complement, purple complement, purple complement, 0.16 choose purple. So that leaves 0.84 that do not choose purple. And this is the reason I mentioned these three do not add up, because it's tempting. 16% want purple. These are the ones that don't want. So 38 plus 36 is 74. But the complement is actually 0.84 because we're missing 10%. So whenever you do complement, do 1 minus the event. So don't try to add up all the other ones, because sometimes you'll be missing something and the complement will not be what it should be. Okay, so 3 non-purples, so that would be 0.84 times 0.84 times 0.84, or 0.84 to the third, put that in the calculator, and we get 0.407296. All right, so again, practice these as much as you need to. You want to get very comfortable, and one goal when taking a math class is you want to be able to work the problems without thinking. It's not that you can do them in 5 seconds. That's not the point. Like you don't need to work all the problems in 5 seconds or 10 seconds. If it can take a minute, but ideally, when you get to a test and you're under a time situation, you would rather not have to think about how to start. So when you see this at least one problem or whatever it is, any of these, it would be better to not have to think about how to start. So get to where that you see at least one. All right, use the complement. That is reflexive, and you don't have to think about it. And again, okay, sorry, the dog started barking. Yeah, so just make sure you practice these enough to where you can get very comfortable, and the more you practice it, the easier these will get. And again, that you can see these are not taking a lot of time, a lot of writing. It's not a dozen lines of problem solving and that kind of thing. It's just very short problems, but getting started is sometimes the hard part. So make sure you email me if you have any questions.